Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Math 221. If you have any questions, please leave them in the comments below. Thank you and enjoy. So we're going to be talking today about indefinite and definite integrals. What is the difference between an indefinite and a definite integral? So we can talk about that first. We're going to get started with indefinite integrals because that's typically what you start with in calculus. Let me write that down. That's a horrible I. Indefinite integrals. These are problems that look like this. First, you need to know how to draw the integral symbol. It looks like a long S, something like this, and then we have some function, like let's say x, and then we have to cap it off with like a dx. So if I were to talk about an indefinite integral, this is what it looks like. Integral, function, dx. A definite integral is going to look something similar, except it's going to have bounds. I'll say what I mean by that in a few minutes. But first, let's take the integral of this. So what is an integral? Well, an integral is the opposite of a derivative. And if you're good at derivatives, then hopefully you're good at integrals. And if you're not good at derivatives, well, then you have absolutely no hope with integrals. So make sure you're good with that first. So let's do this one first. X dx. If I were to ask myself, what is the antiderivative of this? First, I would ask myself, what is the derivative? And let's take another function like x squared, like a function like x squared. If I were to take the derivative of this, I would say to myself, okay, well, I'm going to pull this 2 out in front here, and then I'm going to say the 2 minus 1 power. It's going to become 2x now to just the first power. And this is the power rule. We have a similar rule for indefinite integrals, and that is, well, the power rule for antiderivatives. Notice this is x to the first power, right? So I just need to do the opposite of what I would do for a derivative. So I'm going to add 1 to the power and then divide by that power. So divide by 2 instead of multiply, divide with integrals. So this will become x squared divided by 2. And then at the end of any indefinite integral, we always need to put plus c. Where does that plus c come from? Let's talk about that. So first I just want to say the nice thing about integrals is that you can check your answer to any question that's an integral. How, you ask? By taking the derivative. And if you take the derivative and you get the original function, which again was just x, then you know you got the right answer. So let's do that right here. I'm going to ask myself, what's the derivative of x squared over 2? So following the power rule, the 2 goes out in front, times x now to the first, and then we divide it by 2. The 2's cancel, and you just get x. In other words, this is the correct answer. Now, what about the plus c? Well, I have a question for you. What if I had x squared over 2 plus 1, and I asked you what's the derivative of this? Well, you'd say the derivative of x squared over 2, we just said it, it's x. And what's the derivative of plus 1? It's just plus 0. The derivative of plus 1 is 0. Now, what if I had x squared over 2 plus 10? What's the derivative of that? Again, just x. Notice any number I plug in here, even if it's like minus 1/7, the derivative is going to just be x. And technically I shouldn't draw equal signs, I'll draw like these arrow things, meaning that these are the derivatives. But the point is clear. Plus c we need to include because it could be any of these three. How do I know that the integral is not plus 1 or plus 10 or minus 1/7 or just 0? Right? It could just be plus 0 in the first place. And so to cover every possible situation, we just put a plus c at the end of it, and that covers every possible answer we could have. And yes, you need to put plus c at the end of every indefinite integral problem. Okay, so that's it for the first one. Again, what did we do? We did the power rule essentially backwards. Any questions so far? Okay, great. We've got 20 more problems tonight, and I promise you this, it's going to go much faster than the review, which took, like what, 100 minutes? It was an hour and 40 minutes. So here we go. Here's the next problem. Integral of 3x squared dx. I want to take the integral of this. So again, what am I going to do? Well, first I see this 3 here. What do I do with the 3? It's a coefficient, right? So I'm just going to first pull it outside of my integral because it's just a coefficient. I can do that. As long as it's not an x, as a matter of fact, I can pull it out in front. So 3 integral of x squared dx. Now all I need to do is the power rule. So again, instead of subtracting 1, I'm going to add 1 to the power. And then instead of multiplying, I'm going to divide that by my new exponent, which is 3. This integral will equal 3 because that's, well, the coefficient right there. times x cubed divided by 3, and again we need a plus c at the end of every problem. These 3's cancel. You're going to get x cubed plus c. That's our final answer. Any questions? Okay, let's keep going. Integral of quantity 7x minus 4 dx. Just a quick point on notation. You do need to include parentheses here. Like if I miss the parentheses like this, it would be like forgetting a comma in your sentence. It's grammatically incorrect. So for that reason, you need parentheses between the integral and the dx. Now, notice we have two terms here. We have 7x and we have the minus 4. So what I'm going to tell you is we're just going to take the integral one at a time. So for instance, what's the integral of 7x? So again, this 7 is going to be a coefficient. So I just pull it out in front of my integral. And then the integral of x, we kind of started with it. But if this is to the first power, I add 1, so now x squared, and then divided by that power, so divided by 2. There's the integral of 7x. Now, what's the integral of minus 4? This is a little bit trickier. Well, actually, it's pretty easy if you know the rule. So, if there's no x, I repeat, if there's no x, like minus 4, then that means the integral is you just add x to it. So, it's minus 4x. That's it. That's the rule for just constants like this. And then we're going to add c, and pretty much that's our answer. And one more thing I want to say about that minus 4, that integral of minus 4. If I had the integral of 5 dx, well then that integral would just be 5x. If I had the integral of 11 dx, well then that integral would just be 11x. Oh, and I forgot the plus c, sorry. But that's the point. If you don't have an x in your integral, you just add one and that's the integral. There you go. Easy. Any questions so far? Okay, great. The next one I want you to try on your own. I'm going to give you like 30 seconds, a minute to solve this next one on your own. It's the integral of x divided by 2 dx. I'm sorry, the x cubed over 2 dx. Okay, go ahead and take some time to solve this. If you get stuck, because maybe you're wondering what do you do with this divided by 2, I just want to tell you, remember, you don't have to do quotient rule. This 2 in the denominator is the same exact thing as if you had a 1/2 x cubed dx, right? Like these two things are equivalent. And then the 1/2 is just a coefficient. So go ahead and try this on your own. I'll give you another 30 seconds and then we'll talk about it. Okay, even if you're not done yet, I'm just going to start talking. So this integral is going to be, again, the 1/2 is just a coefficient. I pull it out in front, times the integral of x cubed is going to be x to the third plus 1 divided by that power, 4, and then plus c. And this can simplify to x to the 4th power in the numerator, 8 in the denominator, plus c. There we go. There's our integral. Again, the hard thing about this one, I would say, is sometimes you do see divided by 2 like this. And a lot of times this scares kids. I don't know why. But all you need to do is rewrite it as a 1/2, and then we're good to go. And here's one more before we start looking at some of the annoying ones. Well, actually, this one's kind of annoying. I have the square root of pi dx. What is the integral of this? Notice, is there an x here? No, it is just pi. So if some of you think that we should rewrite it as pi to the 1/2 power, which you could do, I mean, this is true, this would be equivalent, it's not necessary because all we need to do, since there's no x, we just add an x next to it, square root of pi times x plus c. That's it. That's the integral, because pi isn't a variable. Okay, any questions so far? Great. Now let's get to the annoying ones. Instead of the square root of pi, now I'm going to give you the real one, square root of x dx. Ah, darn. Everyone hates this one. I like it because it makes me a lot of money, because people hate it. Now, the square root of x, now we are going to rewrite it as x to the 1/2. We are going to rewrite it as x to the 1/2 because we are going to need a power rule now. So now I need to ask myself, what's 1/2 plus 1? A lot of people think way too long about this question, so here's what I would recommend you do. 1/2 plus 1 is the same thing as 1/2 plus 2/2, right? Which is 3/2. So this integral, or the integral of this, is now x to the 3/2 power divided by 3/2 plus c. Now we can't leave this as the final answer. We don't like complex fractions like this. We don't want to have a fraction within a fraction in the denominator. So instead, how do we deal with that? Well, I'm just going to flip it. I'm going to take the reciprocal and multiply. So the reciprocal of 3/2 is now 2/3. That's times x to the 3/2 power plus c. That's a much better looking final answer. And yes, I'm going to do that all the time. And if you want to, and you see that you're dividing by 3/2 and instead you just want to go straight to multiplying by 2/3, you can do that too. I'm typically going to write out the intermediate step though, that 3/2 in the denominator, just so you guys are following along. Okay, any questions? Next one, another down-home favorite. We have the integral of 1 over x squared dx. So there's two ways you could do this. One is the quotient rule, and two is rewriting this with a negative exponent. I recommend doing the second one for two reasons. Number one, it's better to rewrite this as a negative exponent, like integral of x to the negative second power dx, because now it's a simple power rule, right? This is easy. The other reason you don't want to do quotient rule for this one is because quotient rule doesn't actually exist with integrals. That's right. Quotient rule, product rule, and chain rule don't exist in integrals. They only exist in derivatives. Well, then how do we deal with a problem like that if we had derivatives, product rule, quotient rule, or chain rule? How would we take the integral of that? That's a great question. We're going to be talking about it later today. So stay tuned. So first, let's take the integral of this, x to the negative second power dx. Some people will say, well, we all know we're adding 1. Some people will say x to the negative third power. Those people are fools. They're not paying attention. Negative 2 plus 1 is minus 1. And then we divide it again by minus 1 plus c. You can keep this as your final answer. If I was your professor, I would accept this. I would also accept 1 over negative x plus c. And why would I write it like this? Well, because x to the negative first power is just 1 over x. Okay? So this is acceptable to write as well. Any questions so far? Okay, great. The next one here is another one I'd like you to try on your own. It's not fun, I promise. Unless you like fractions, which I'm assuming is none of you. We have the integral of x to the 4/5 power minus 1 over x to the 2/3 power dx. Oh, need to put this in parentheses like this. Okay, now I'm going to give you a minute to start solving this. I'm also going to give you a 30-second head start, and then I'm going to start going. I won't talk. I'll let you keep going. I'll just be quiet, but I'll start writing. And you know what? I'm going to stop talking right now. Just go ahead, try this integral. I'll catch up with you in a second. Okay, time's up. Again, if you didn't get an answer, that's fine. But let's talk about what we did here. So first, hopefully you did x to the 4/5 plus 1, which is also 5/5. So you got 9/5 for that power, which is how I got x to the 9/5 right here. Again, divided by 9/5, and we can even see in the next step that I rewrote it as 5/9 here, like that. Hopefully that makes sense. We're all good. And then for the x to the 2/3 power in the denominator, remember, that can be rewritten as x to the negative 2/3 back in the numerator. So what I did was I said negative 2/3 plus 1, or 3/3, is equal to now positive 1/3. That's how we get x to the positive 1/3 divided by 1/3, which really is the same thing as multiplying by 3 over 1, which technically 3 over 1 is just 3, so I don't even need the divided by 1. And there we go. That is the answer to this one. And don't forget the plus c, of course. Any questions on this one? Okay, I promise we're done with the crazy fractions for now. Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks everyone. Bye-bye.